welcome back to my channel. So we are continuing the 5th chapter arithmetic progression, and today we are discussing about the nth term of an arithmetic progression. If you are new to the channel, don't forget to subscribe. Also watch the previous video before watching this. So let's start. Now let's see the nth term of an AP. In the previous video, we have seen what is an arithmetic progression. So arithmetic progression is a list of numbers where the common difference between two consecutive numbers is always constant. So the succeeding number is formed by adding a fixed number to the preceding number. So nth term of an AP, the n represents the position of the term in a given AP. N represents the position. So let's see, we know 1, 2, 3, 4, 5, 6, 7, 8 is an arithmetic progression, which is a natural numbers. So what is the position of each term is represented by letter n. So n represents the position of the term in a given AP. For example, 1, 2, 3, 4, 5, 6. So here what is the position of number? The 3. The position of 3 is third term. So this is the third term in this AP. So n represents the position of the term in a given AP. Now let's see an example. Determine the 10th term of the arithmetic progression 2, 7, 12. So we have given only the first 3 terms. We need to find the 10th term. So we can do that manually. How manually we will do? So first we will find the common difference. So the d is equal to 7 minus 2. The second term minus the first term, which is 5. So with the common difference we are able to form a arithmetic progression, which is a manual one. So let's form it, because we know what is the standard formula for arithmetic progression, which is the standard formula is a, which is the first term. The second term will be a plus d. The third term will be a plus 2d. Then a plus 3d. The fourth term will be a plus 3d. A plus 4d. A plus 5d. A plus 6d. A plus 7d. A plus 8d and a plus 9d. So this will gives you the 10th term. A plus 9d is your 10th term. So this is how we find the nth term of a arithmetic progression manually. So let's write this. So a is here is 2 and the common difference is 5. So the second term will be 2 plus 5. Third term will be 2 plus 2 times 5, correct? And third term will be 2 plus 3 times 5. Fourth term will be 2 plus 4 times 5. 1, 2, 3, 4, 5. So that will be sixth term will be 2 plus 5 times 5. Seventh term will be 2 plus 6 times 5, which is eighth term will be 2 plus 7 times 5, and the ninth term will be a plus 9 times 5, and 10th term will be a plus 8 times 5. Here it is 8 times 5 and a plus 9 times 5 will give you the 10th term. Let's see the values, which is 2 is the first term, 2 plus 5 7, so that will be 12, again 12 plus 5, that will be 17, 22, 27, 32, 37, 42. How many it is? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 term, that is a plus 42, 47. So the 10th term is 47. So now here we find the 10th term by using the standard form of an arithmetic progression. So it will be difficult if we are requested to find the 100th term. So it's not possible to find this way. So there is a formula to find the nth term of an arithmetic progression. So here we can say, here if you want to find the third term, so what is the formula to find the third term? So that is a plus a is the first term plus 2d. 2d. So d is the common difference and here it is the 2. So this is the formula to find the third term. So means that is n. If 3 is the position of the arithmetic progression, so then 2 is 1 minus the position. So if we want to find the nth term of a arithmetic progressions. So this will be n minus 1. So that will be n minus 1. So then the formula is a plus n minus 1 into t. So this is the formula to find the nth term of a arithmetic progression. So I hope you understood. So what is the here? Let's write that here, 2 plus 5. The second term was 2 plus 2. This is the third term. And see, 2 plus 3 times 5. So this is first, this is second, this is third, this is fourth term, and fifth term was 2 plus 4 times 5. So here we can see the first, this is A and this is D. 5 is the common difference. So 4 is this is the fifth term in this arithmetic progression. So 4 is n minus 1. So that is the position, which position we have to find, that minus 1. So the formula is a plus n minus 1 into d. So this is the formula to find the nth term of an arithmetic progression. So let's say, let a1, a2, a3 be an AP. So a1 is the first term, a2 is the second term, a3 is the third term, and the common difference is d. The common difference is d. The second term is a2 equals to a plus d, which is the first term plus the common difference. So again we can say that d is the common difference. So that is a plus d equals to a plus 2 minus 1 into. So that is the if it's the second term, then minus 1. The second term, the position minus 1 will multiplied by common difference. So similarly, the third term will be a plus 3 minus 1. 3 is we are finding the third term, so that minus 1 multiplied by the common difference. If you are finding the fourth term, again a plus 4 minus 1. 4 minus 1, which is we are finding the fourth position term. So that is 4 minus 1, a plus 4 minus 1 d. So in looking the pattern, we can say nth term. So any term in which position we need to find, that will be a, which is the first term, and n minus 1. So which position we are finding, the position of that term minus 1 multiplied by the common difference. So this is the standard formula to find the nth term of a arithmetic progression, which is a plus n minus 1 into d, where a is the first term and d is the common difference, and n is the position of the term. Let's see the answer for the previous question by using the formula. So previous question we have asked to find the 10th term of this arithmetic progression, which is 2, 7, 2. We find the 10th term, which is 47 manually. Manually we find the 10th term. So now let's put that into the formula. So which is a plus n minus 1 into d. The nth term formula is a plus n minus 1 into d, where a equals to 2 plus n minus 1. We are asked to find the 10th term, which is 10 minus 1 into d. Common difference here is 5. So 2 plus 10 minus 1, 9. 9 times 5 will give you 45. 2 plus 5, which is equals to 47. So here also we find 47 as the nth term. By using the formula, it is very easy to find the nth term, which is 47. Now let's see few examples by this application. Which term of the AP 21 given arithmetic progression, which is 21, 18, 15 is 81. Also is any term 0. Give reason for your answer. So we have given an AP and we need to find the position of minus 81 in the given AP. Also we need to see whether 0 is a term in the given AP. So first we can say the A here is 21 and common difference is 18 minus 21, so that will be minus 3. And what is the formula to find the nth term? So which is an equals to 2a plus n minus 1 into d. Correct? So we know what is an, which is the nth term is 81 minus 81. Minus 1, 81 equals to a is 21. 21 plus n minus 1. We don't know what is n minus 1. The common difference is minus 3. Correct? So that is minus 81 equals to 21 minus 3n plus 3. Correct? So that is minus 81 equals to 24 minus 3n. We can write 3n equals to 24 plus 81, which is 3n equals to 105, correct? So n equals to 105 divided by 3, which is 3, 15, 35. So the 81 minus 81 is the 35th term of the given AP. Minus 81 is the 35th term of the given AP. Now we need to see whether 0 is any term of in the given AP. Let's see how we can find that. We need to find the position of 0 in the given AP. If there is anything. So let's put that again in the formula, which is a plus n minus 1 into d equals to 0, correct? So a is equal to, we need to find if there is any n value for if we put the values in this formula. So a is equal to, a is given, a is 21, a equals to 21 plus n minus 1, we don't know the n value, and d is minus 3 equals to 0. So that is 21 minus 3n plus 3 equals to 0. So that will be 24 minus 3n equals to 0. 3n equals to 24. n equals to 24 by 3. n equals to 8. So yes, we can say 0 is the 8th term in the given AP. 0 is the 8th term in the given AP. Let's see another question. Determine the AP whose third term is 5 and seventh term is 9. So we need to find the arithmetic progression, but we have only given the third term and seventh term. So we know what is third term, which is A3 is equal to A plus n minus 1 into d. So that is A plus n minus 1. So this is the third term. So that will be 3 minus 1 into d equals to 5, correct? So this is the third term, formula for the third term, and we have given the seventh term is 9. So that will be seventh term means that will be a plus n minus 1, that is 7 minus 1 into d equals to 9. So we got that is a plus 2d equals to 5 and a plus 6d equals to 9. So we got here one equation and another equation. So we have got a pair of linear equations in two variables. So remember we learned this in the chapter 2, which is a linear equation, pair of linear equations solving. So now we can solve this by elimination method. So we can eliminate a from this equation by subtracting equation 2 to 2 and 1. So by subtracting equation 2 minus 1, we will get 4d equals to 4. So d is equal to 4 divided by 4, which is 1. The common difference here is 1. Now let's find which is a. By substituting the value of d in the formula, we will get the value of 1 d. A. So that is a plus 2d equals to 5. A plus any of the equation we can substitute the value. A plus 2d equals to 5, which is a plus 2 multiplied by 1. We found the value for d, which is 1 equals to 5. So a plus 2 equals to 5. A is equal to 5 minus 2, which is 3. Correct. Now we find the first term, which is a is 3. Now let's form an AP. So the first term is 3 and the common difference we found it is 1. So the second term will be 4. Third term will be 5, 6, 7, 8, 9. So 9 is given as 7th term. We can see 1, 2, 3, 4, 5, 6, 7. The next term will be 10, 11, 12. So this is the required AP as per the question. Now let's see the next example. Check whether 301 is the term of the list of numbers 5, 11, 17, 23. We need to see whether 301 is the term in the given AP. So the first given AP we know 5, 11, 17, 23. So the common a equals to 5 and common difference equals to 11 minus 5, which is 6. the common difference is 6 and A is 5. So we need to see the position of 301 in this given AP. So nth term equals to n minus A plus nth term equals to, we can write as an equals to A plus n minus 1 into D. So an equals to 301, which is equal to A equals to 5 plus n minus 1 into 6. Correct? We don't know what is the position n here. So which is, we can solve this. 301 equals to 5 plus 6 n minus 6. So 301 equals to 5 minus 6, that is minus 1, 6 n minus 1. So 301 plus 1 equals to 6n. We can write 6n equals to 302. N equals to 302 by 6. So that is, so this check whether, so we can say this is not divisible in 302 divided by 6 will give you a decimal figure. So we can say 301 is not a term. This 301 is not a term of this AP, is not a part of this arithmetic progression. Now let's see the next example. How many 2-digit numbers are divisible by 3? So we need to know how many 2-digit numbers are there which is the multiples of 3. So we know which is the first, which are the multiples of 3, and which is the first 2-digit number which is multiple, which is a divisible by 3, which is, we can say 10 is the first 2-digit number but it is not a divisible of 3. So 12 is the first 2-digit number which is in the table of 3, which is divisible by 3. And second is 15, we know that this is in the table of 3, multiplication table. Then again 18, again 21. So we know we need to find how many numbers are there which are divisible in, how many 2-digit numbers are there which are divisible by 3. And if you see the last, we need to find in an arithmetic progression, we need to find the nth term as well. So here the highest 2-digit number is 99, right? Highest 2-digit number is 9. Whether it is divisible by 3, yes, we can say this is divisible by 3, which is the, so then we can say it is higher, nth term is 99. Now we need to know how many terms are there in this AP. So the nth term, the formula is nth, an equals to A plus n minus 1 into D, correct? So we know the nth term, which is 99. We just need to know the position of this term. So then we know how many, what is the total numbers which are 2-digit numbers which are divisible by 3. So the nth term is 99 and A is 12. 12 plus n minus 1. We don't know n minus 1, and the common difference here is 3. Correct? So that is 99 equals to 12 plus 3n minus 3. Which is 99 equals to 12 minus 3, that is 9. 9 plus 3n. 99 minus 9 equals to 3n. So that is 3n equals to 90. N equals to 90 divided by 3, which is 30. So 99 is the 30th term of in this AP. So we can say there are 30 numbers, 2-digit numbers which are divisible by 3. There are total 30 numbers which are divisible by 3. A sum of rupees 1000 is invested at 8% simple interest per year. Calculate the interest at the end of each year. Do this interest form an AP? If so, find the interest at the end of 30 years making use of this fact. So we need to find the interest, simple interest per year. So we know what is the formula to find the simple interest. Simple interest formula is principal multiplied by rate of interest multiplied by term. Correct? So that is for first year. The interest for first year will be, principal amount is 1000 multiplied by 8 by 100, which is the rate of interest multiplied by first year. So that will be 100, it is 1000, sorry. So that will be 2 will be reduced. So that is 80. The interest for the first year, interest for First year is rupees 80. Correct? Similarly, we can see for the second year, which is a simple interest. For second year, the interest will be 1000 times 8 by 100 divided by period, which is 2 years. That will be rupees 80. That will be 160. Correct? And for the third year, let's see whether this forms an AP. So that is 1000 multiplied by 8 by 100 multiplied by 3, which is the period, which is equals to rupees 240. Correct? 240. Does this forms an AP? So here we can see the first term is 80, the second term is 160 and 240. The common difference here is 80. So A equals to, the first term is 80 and the common difference is 80. Correct? And it also forms an AP because the common difference is same between two consecutive terms. So this is an AP. This is an AP. Now we need to find the interest at the end of 30 years. So we need to find the interest at the end of 30 years. So we need to find the 30th term. So and 30th term, which is the interest for 30 years, will be, the formula will be A plus n minus 1 into t. So 30th term, which is A equals to 80. 80 plus n minus 1. So that is 30 minus 1 multiplied by the common differences again 30. So that is 80 plus 30 minus 1, 29 multiplied by 80. So that is 29 times 8 will give you 2 times 16, 16 plus 1, 23, 2320. So that is 80 plus 2320, which is equals to 2400. So the interest for the 30th year is, they have asked for to find the interest at the end of 30 years. So end of 30 years, the total interest will be rupees 2400. Now let's see the last question from this example. In a flower bed, there are 23 rose plants in the first row, 21 in the second, 19 in the third, and so on. There are 5 rose plants in the last row. How many rows are there in the flower bed? So we have given the first row has 23 rose plant and the second one is 21, then 19, then and the last one has 5 rose plants. Does this forms an AP? Let's see the common difference between two consecutive numbers is same. So what is the difference between 23 and 21? So that is minus 2. Again it is minus 2. Correct? So this forms an AP. Now we can say A equals to 23 and D is equal to minus 2. And we know the last row has 5 rose plants. We need to find the number of rows in the flower bed. So number of rows, which is the position of, we need to find the position of 5 in this given AP. So the formula to find the nth term is AN equals to A plus N minus 1 into T. So the AN, the nth term is 5 here and A is 23, 23 plus N minus 1. We don't know the value for N. N minus 1, D is equal to minus 2. Common difference is minus 2. So that is 5 equals to 23 minus 2N plus 2. Correct? So that is 5 equals to 25 minus 2N. We can take 2N here. So that is 2N equals to 25 minus 5. 2N equals to 25 minus 5, which is 20. N equals to 20 divided by 2. N equals to 10. So the flower bed has 10 rows. So 10 rows in the flower bed and it has 5 rose plants. So the 5 is the 10th term of this AP. I hope you are clear how to find the nth term from given different situations. In next video, we will see how to find the sum of an arithmetic progression. If you are new to the channel, please don't forget to subscribe. Thank you for watching.